Welcome back, everybody. Today we're going to start talking about trigonometry. Now, this particular lesson is going to be a lot of definitions. Most people think it's boring. I don't necessarily like teaching definitions, but this lesson is particularly essential because if you don't know the true meaning of a word, when the word is repeated over and over and over again throughout the whole section, you're going to be lost. So it's one of those things where this is essential to a good basis for all the trigonometry that you're going to learn. All right, so sit back. Hopefully this won't take too long, and we'll try to get everything in that we can. All right, so in order to start talking about trigonometry, we got to start talking about angles. All right, and in geometry, an angle is the set of points determined by two rays that end at the same point. All right, an angle is a set of points determined by two rays that end at the same point. So if I were to draw out the two rays like that, the side where the angle starts is called the initial side. I can't write today, so IN. Initial side. The side where the angle ends is called the terminal side. The point where the two rays meet is a very special point called the vertex. These three names are essential, mostly because I'll use them quite a bit in all of my trigonometry lessons. Now, angles are measured in units called degrees. All right, now typically in trigonometry, we use letters like alpha, beta, or even theta to denote angle variables. So for example, in this angle, I would say the measurement is theta, just as in algebra, we typically use x and y. Here we'll use alpha, beta, theta, that kind of a thing. All right, there are a couple of special angles. One is called a right angle. Right angle is where theta would equal 90 degrees. Okay, and that looks like a corner. A straight angle where theta equals 180 degrees. And that looks like right? There's your right angle. There's your theta, right? It's 180 degrees. All right, there are a couple of other types of angles. There's such a thing as an acute angle. An acute angle is less than 90 degrees. So 0, theta is between 0 and 90 degrees. 0 degrees and 90 degrees. A picture would kind of look like that. Obtuse angle where theta is greater than 90 but less than 180 degrees, because once you hit 180 you're getting your straight angle. But here is a picture of that. So it's greater than 90, less than 180. All right, and then there's such a thing as a quadrantal angle. A quadrantal angle, all right, has its initial and terminal side on axes. So its initial side and terminal side are on coordinate axes. So I'm going to change color so you can see it. So here is my initial side. And here is my terminal side. And it doesn't matter. This could be theta. Or that could be theta. We can talk about angles going in different directions in a little bit. But that is called a quadrantal angle. All right. Now, one more thing with angles. You could have something called a complementary angle. And complementary angles add up to 90 degrees. So alpha plus beta must equal 90 degrees for the two angles to be complementary. Or you could have supplementary angles. And that's where the two angles, we'll call them alpha and beta, add up to 180 degrees. All right. So let's start. Let's talk more about angles. There's such a thing called standard position. And standard position just tells you that your initial side is on the positive x-axis. So if I say an angle's in standard position, the initial side is on the positive x-axis. The terminal side could be anywhere. So just because I drew it in quadrant 2 doesn't mean anything. Could be in quadrant 3, could be in quadrant 1. It doesn't matter. All that matters is in standard position, your initial side has to be on the positive x-axis. All right. So another thing with angles, you could have something called a here I'm going to use blue because it's a little darker. Coterminal angles. All right, and coterminal angles have the same initial and terminal sides. So for example, I'm going to draw two angles. So I'm going to draw a here. There's there, and there's there, and this is 30 degrees. Or I could have this angle, which is 210 degrees. Notice that they have the same initial and terminal sides. So if they have the same initial and terminal sides, they are coterminal. All right. So let's do a quick example. Not going to be too much math here. So if theta equals 60 degrees in standard position, find two coterminal angles. B, an angle complementary. And C, an angle supplementary. Hang on, I can write that better. All right, so a fairly typical question for people just starting out here. Hopefully this is something that you guys have seen before. So for two coterminal angles, first I'm going to draw it in standard position. There's 60. All right, now if I go all the way around the circle and go an extra 60, so I went 360 degrees and an extra 60 degrees. So that makes the whole thing not 424, 420, 420 degrees. So this is the first coterminal angle. And if I add another 360, right? Because what if I were to simply go around and around and add another 60? Well, I would have 360 degrees plus 360 degrees plus another 60 degrees, which would be 780 degrees. So there are two coterminal angles. Now for an angle complementary, all right, so this is A. So for B, we need an angle complementary. So that means 60 degrees plus beta equals 90 degrees. So pretty easy. Beta equals 30 degrees. There's an angle complementary to 60 degrees. And now for C, we need an angle supplementary. So that means 60 degrees plus beta equals 180 degrees. So beta must equal 120 degrees. Again, like I said, the math is not overwhelming here. It's just a matter of knowing what the words mean. That's why I say that it's very, very important. Now with my initial A, two coterminal angles, I went around once and twice. Now notice, every time I draw an angle, all right, so let's say I'm going to draw a 45-degree angle in standard position. I'm always going counterclockwise. Well, here's a question. Can I go clockwise? The answer is yes. Now, how do I know the difference between a counterclockwise 45-degree angle and a clockwise 45-degree angle? Well, it's pretty easy. The clockwise one is just negative. So anytime you have a negative angle in standard position, it just means you're going clockwise instead of counterclockwise. So all it does is show direction. All right, so that would be negative angles. All right, now I want to talk about radians, okay? Now, degrees are units of measure. All right, so when we're applying trigonometry to other things that have units like feet, miles, meters, kilometers, we would have to do some sort of a conversion. That way we could use the measurement of 30 degrees or 60 degrees or whatever the angle measures and combine it with, again, the other units we're using. So mathematicians developed a thing called a radian. Now basically what a radian is, if I take my circle, all right, and of course this is a better circle that I can free draw, but I'm just giving you an example. Here's my radius. Basically what I want to do is I want to take this radius and I want to measure the length around my circle. So every length that you go, so like that would be the length of the radius overlaid on the circle, would be 1 radian, right? If I lay it down again, there would be 2 radians, then 3 radians, then 3.14 radians. 3.14 is a very unique measurement, all right? It's pi. So pi radians will get you halfway around the circle. And you can continue overlaying that radius around your circle until you get here, and it's 6.28 radians or 2 pi. Now, radians are not units. That's why we're able to use them with feet, meters, miles, those kind of things. And it makes angle measures a much more flexible measure that can be applied in the real world to so many different things. Now, if I write something like alpha equals 5 degrees, right? The degree symbol is there, so it has to be 5 degrees. If I were to write alpha equals 5 with no degree symbol next to it, you have to assume it's radians. All right? Now, 1 degree equals pi over 180 degrees. All right? That's a conversion to radians. Or 1 radian equals 180 degrees over pi. And that would be a conversion back to degrees. All right, so in order to use degrees and radians flexibly, we have to be able to convert from degrees to radians and back again. So let's try a couple. All right, let's use these two equations and let's try a couple. So I have alpha equals pi over 6. I have beta equals 4 pi over 3. I have theta equals 60, we'll call it 45 degrees. Why not? All right, so I have 3 of these, and I can generate as many more as we need. But let's do the work. So if I'm converting from radians to degrees, all right, this is what I always had trouble remembering which one to use, all right? So notice if I'm converting to degrees, I need my degree units in the numerator. So what I need to do is I need to multiply times 180 degrees divided by pi. All right, now my pi's will cancel, and I'm left with 180 degrees divided by 6. And if I divide it by 6, I get 30, and my units come along, degrees. So pi over 6 equals 30 degrees. Pi over 6 is in radians, 30 degrees is obviously degrees. Let's try that again. All right, so I'm going to multiply times 180 degrees divided by pi. And again, I'm going to switch colors. I'm going to cancel my pi's. All right, my 3 can cancel with my 180 and become 60. My degree units don't cancel, they stay there. So then I have 4 times 60 degrees is 240 degrees. Now to go from degrees to radians, I'm going to now, I need my degree, notice my degree units are in the numerator and denominator. And when you have like units in the numerator and denominator, what can you do to them? You can cancel. So I can cancel my degree units, and I'm left with 45 pi over 180, right? No more units, notice. And the 45 and the 180 can cancel, right? I can put 5 into both of them. So I get what? 9 pi, 5 goes into 180, 36 times, 9 pi over 36. And can I cancel that again? I sure can. Right, because 9 goes into 9 and 9 goes into 36, and I'm left with pi over 4. So you see how those units cancel, and we're left with something without units. Let's try 1 or 2 more. So if I said theta equals, let's say, 360 degrees. That's once around the circle, right? So I want to multiply that times pi over 180 degrees. Now again, my units cancel, and I'm left with 360 pi over 180. Notice there's no units, and 180 is half of 360, so we're left with 2 pi with no units attached. All right, so there wasn't a whole lot of math in this one, but there was a lot of essential information that you need. All right, so keep this handy when you go through the different problems. Make sure you know what those words mean. If you know what the words mean, the problem becomes much, much easier. All right, guys, thank you for listening. There's a lot more practice ahead, but I'll see you guys next time. All right.